From automation to autonomy, we are talking about Fastweb plus Vodafone, the new operator coming from a merge of two operators in Italy, with one strategy, one objective, that is the fact of reaching by 2030 the autonomy of the network at the level 4, mostly at the level 4, where makes sense, where convenient, working across all the domain of our network, intent-driven operation concept that on the chart we all know. And the starting point is the one that is common in many of the CSP. Traditionally, when you have the single operator, data and system are fragmented. Consider then when you are merging two operations into one, two set of OSS, BSS into a single one, and trying to compete in the market. Clearly, we are facing also a network complexity because there are also overlap. Vodafone, mainly on the mobile, but having also the broadband, the fixed broadband, same for Fastweb. And that was the situation 2 years ago, an operation that was pretty reactive when it comes to managing incident. That's why we have this program in 3 phases. The first that we started last year, currently we are in the delivery phase, foundation and the initial set of agents, the initial set of agentic helping us in our operation. Foundation, very important, data. The same data that are expected to be reliable, complete, etc., in order to enable us to scale AI responsibility. Then the second phase, we will start closing the loops, at least at the domain level, continue our evolution on the data platform, and then the third phase, the final one, to reach the autonomy, working in our closed loop at service level, so cross-domain. Foundation. Here comes why we needed Carla and Celfocus to enable us developing our initial consolidation of the network, the logical one, with the digital twin.
Yes, thank you. Thank you, Mario. So in fact, the data foundation is key. It's where we combine topology, telemetry, and performance data to build a digital representation that mirrors the physical network and behaviors happening in real time. And that representation is the digital twin that allows us to move beyond reacting to actually predicting and simulating different network scenarios. So think of the network as a city map. So sites are the neighborhoods, links are the roads, telemetry are the traffic cameras. And the digital twin acts like the traffic control room that in fact is predicting jams and redirecting the flows. So these simulations within the digital twin provide clear, actionable insights and context that agentic AI can use to orchestrate end-to-end decision making. So together, digital twin and agentic AI form the basis of the solution that we have been building together with Fastweb for autonomous operations. This is an illustration of the sites and the different connections between the sites. I think it's very beautiful, very fancy. It's
there are
like
posters available outside.
Not yet, but we'll try to arrange that. It looks like a painting. What is most interesting about this one is that, in fact, it comes from the real network, the real Fastweb's network. So where did we start? The first use case that we implemented was change impact assessment. What is it? Assessing service and customer impact before implementing a network change. So the existing approach was mainly manual, with engineers pulling data directly from the different data sources, so CMDBs, network manager, tools, inventory, tickets. And as you can imagine, this process is slow, error-prone, and knowledge-dependent. So the solution that we built focuses on the digital twin to have a unified representation based on graphs that could enable this type of analysis and simulations. And these moves from a reactive, from manual checks, to proactive, automated evaluation of the planned works. And you can imagine this is now a much faster process with less errors, also with reduced customer impact, and in fact it is enabling simulation, prioritization, and risk-based scheduling. The second use case that we started and implemented is root cause analysis. So the idea, very simple, to identify the origin for a given fault in the network. So the operation teams today struggle a lot. They can take hours to identify the problem for a given issue. And, well, there are many alarms being received from different network domains, and this makes the process very hard because it is very difficult to correlate this information. For instance, IP teams often cannot tell if a given issue is in fact being caused in the transmission layer. So the idea is also to create a solution that can automate this type of correlations, combining the real-time alarms with agentic reasoning while keeping human validation to guarantee that we can further iterate and confirm the results. And this changes, or this moves or turns a chaotic situation into a very controlled one. Because here we can reduce alarm noise, we can have lower minimum time to detect and resolve with explainable RCA to guide the next steps. So let's now open the hood and take a sneak peek at how we are representing this type of information in a knowledge graph that underpins the digital twin. So here you can see several locations, several sites. Now we will deep dive into a specific one, check some devices that are associated to this site. Each device has its own representation, so it has shelves, slots, cards, subslots, subcards, and also each one of them has a set of attributes that you can check here on the panel, this right panel. And also very important, they have ports. That's how we connect devices to other devices that may be different locations forming circuits. And this is a different type of circuit, a ring network topology, also as an example. And this short demo shows that we can take dispersed data from different inventories and in fact transform it into a single unified view of the network, and we can explore the network as a graph with queryable paths, relationships, and dependencies. So now let's see how this type of representation in fact enables change impact assessment. And you'll see that it's very easy and a very simple process nowadays to check what is the impact or who are the customers impacted by a planned intervention on a specific node. And it's as simple as running a query, okay, and we'll get the immediate results. Who are the customers impacted here, broken by customer type. And this last example, here we have a hierarchy with transmission circuits and also access circuits. And what we are showing here is that is, again, very easy to identify the change impact. And if we have impacted customers, not only in the transmission circuit that we are querying, but also in the access network, we can get both results, okay? So this, also, again, short demo, truly shows this cross-domain view showing how easy we can, with the right representation, map and link these two network domains so that in the end we can have a full impact assessment. So the intelligent automation solution is powered by AWS technology and is built on proven experience and capabilities in digital twin and agentic AI. As you can see there, the digital twin is built for scalability. Okay, this has already or almost 100 million nodes with almost 120 million edges, so the connections between the nodes. The proactive change assessment is already automated and it's already a reality, and a process that could take around 30 minutes, now it ends in less than 1 minute. And these are our targets for the root cause analysis. So it is expected to decrease in 85% the alarm volume, in 40% the minimum time to repair in remote repairs, and also we are expecting 20% decrease in manual alarm checks. So now I'll ask again Mario to conclude and to share what have been the key success factors so far in this journey.
So let's start from the first, is 5 to 6 year transformation. And of course, also financial-wise, something significant. That's why we decide not to go for enabler implementation or investment on enabler per se, but always having the enabler deployed with use cases. So with a financial return in every step of our implementation. That's why, yes, we are talking about the digital twin, the enabler, but in the first deployment, use cases that are giving us tangible result. The second one, the open architecture. In these 5 to 6 years, things will change. This is the reason why it's important in every step having an open architecture. In our case, it's even more important. We are coming from 2 operators. If I'm waiting the physical consolidation, I will wait the 2030 without delivering anything. I need also to use part of the legacy that I have. That's why we need to decompose the monolithic solution into pieces, ensure the open interface, and then having the possibility to compose. The third, the partner with a proven experience. This is not a pure technical implementation. You need the knowledge of what a network is, the process that you are serving. So you need a partner that is conscious of what operation means, what a network is. And last, do not underestimate what instead you as an operator have to spend in terms of effort. There's a lot of validation, because as I mentioned, and also Carla was mentioning, is the outcome of collecting data from dozens of systems. Then your digital twin needs to be validated by your engineers, by your operational teams. Otherwise, you will never trust the result of the change impact analysis. You will never trust on that 80% of reduction. Those are the key success factors so far, and year by year we will be able to tell you others. Thank you.
Thank you.